Hi, and welcome to Mplus Workshop 4 Demo 15. In this model, we're going to be looking at a structural equation model with a measurement, or what would be called a CFA component. We're going to run this model. It contains both a structural and a measurement component. In order to do that, we need to make sure that the measurement model is acceptable, meaning it meets psychometric properties of reliability, validity, and measurement invariance. That's something that I'm not going to be doing in this particular section. We'll talk about that when we talk about CFA in the future. Measurement models within a regression path model allow us to estimate measurement error, and it's just a reminder, in OLS regression, the assumption is that all the observed variables are measured with perfect reliability, and of course that's unrealistic. That's one of the really great aspects of structural equation modeling. And finally, just a reminder again, we'll talk about all of this more when we talk about CFAs. So our model for Demo 15 comes from the KFT, that data from Germany on student abilities, quantitative, nonverbal. And using the KFT data, we have a structural equation model here that consists of a measurement model with two latent variables. So here's one latent variable. This refers to KFT in, which is the nonverbal abilities, and it's measured using two observed variables, and then this latent variable predicts this latent variable. This is the nonverbal, predicts the quantitative, which is measured by two quantitative observed variables. Now I have the variables, the latent and the observed variables, labeled in the same way in this diagram that I have them labeled in the Mplus syntax, but these errors are labeled differently. For the error terms, I use E in 1, E in 2, E in 3 to represent the errors on the N nonverbal side, and EQ 1, 2, and 3 to represent the errors on the quantitative side. And the errors stand for different things. I'm not going to get into all the details just this time, but I do want to show you, in case you're interested in doing something like this, just sort of an example of running a model like this, and then one of the things that we can do. Now, one of the issues with using confirmatory factor analysis or using a measurement model in a structural model is that the first indicator listed is fixed to a loading of 1 because the algorithm needs a metric. This can be adjusted. Now remember, when you're doing this, there has to be some metric that's set to 1 in order to be able to compare everything to that metric within the measurement model. In different programs, like in Amos, it's really difficult to change that, but in Mplus it's actually really simple to change it. In the event that you wanted to take a different approach, you wanted to have perhaps set your metric based on the variances instead, and we'll show you an example of that. All right, so this is not going to be a long video. Well, it might be, but I'm going to go right to running the model in Mplus. All right, I'm going to start by showing you here the KFT dat file. Again, this is not a summarized file. This is actually a full data file, and that's what will be used for this running Mplus this time. And here is the INP file. So this is Demo 15 Part 1. This shows the specification of a simple latent regression model. It is actually shown in Figure 3.5 in the Christian Geyser Data Analysis with Mplus program in that particular book. And it shows a prediction of the KFT-Q by KFT-N at the level of the latent variables. It describes what all of those factors are and how they're measured, and that one is regressed on the other. So there is our data file. Listwise is on to make that is, again, one of the features if you want to be able to compare your results when you're using a full data set to something else that has deleted missing values on a listwise basis. Here are variable names. These are only the variables we want to use, and then we have some missing values. So we want to tell Mplus about our missing value code. Again, analysis type equals general. And now we're going to get into the meat of the situation. So here we have a latent variable by two observed variables, and another latent variable by two observed variables. A good way to think of this is that these are the measurement models, and the by is an easy way to remember that is that this is measured by. Thirdly, we have that the latent variable quantitative is regressed on the latent variable of nonverbal. So let's run this model and see what happens. All right. And I will not spend as much time talking about p-values and chi-square tests and all of that. All of those types of questions need to be answered for pretty much all models, but I don't have time to talk about them with respect to all models. So right now I want to talk about exclusively what we're seeing here. So we see the regression loads for this newly created variable by these two variables, the Q1 and Q3. And you see that Q1 is being set to a 1, and Q3 is then estimated at 0.903. Qn1 is getting set to 1, and N3 is getting estimated at 0.652. And then we have a regression equation where one of the latent variables is regressed on the other. We also have intercepts, we have variances, and we have residual variances. So we have a lot of things that are being estimated. But what if we decided we wanted to use a different technique for providing our metric? And let's say we wanted to use variances instead. Well, I'm going to show you that. That is a part of Demo 15 Part 2. And I'm going to open that up and show you that. All right. So in this one, all loadings are freely estimated and factor variances and residual variances are fixed. So that's how we identify this model. So in order to do that, we actually put this little asterisk here. So it's always the first one that's set to 1. So by putting an asterisk after it, it sets the loading free using the star. And instead, we're saying that the latent variable residual is going to be set to 1 for each of these. Now you can do that instead of the original factor loadings method for setting your metric. Either way, it just depends on the context, and it's beyond, unfortunately, beyond our work here together. If you'd like to send me an email and we can talk about this at another time, I can send you to some additional references in order to be able to look into this more. But it really depends on your application, which way you want to do it. So I'm going to go ahead and run this. Look at the results. And here are the results. You can see now that the factor loadings are over 1 in each of these cases. But the residuals here for N is set to 1. So that and this residual is set to 1 as well. And so that sets the metric. So, and that is constrained. So that sets the metric for the entire model in order to be able to do the calculations for all the other factors. Just a reminder, again, we can look at the diagram. Let's see if I can, I'm going to pause this and see if I can expand. All right, so here we can see the entire model, similar to what we had in our PowerPoint, but now we have the coefficients as well as factor loadings and variances all kind of identified here. And I'm trying to move it and I'm not having too much success. There we go. All right, so you can see all that. And that will that hopefully will help you to be able to understand how a A measurement model and a structure model can be used together. And that's all I'm going to say about that at this time. We will look at more in-depth analysis for factor analysis and structural equation models when our issues are different at different points in time. Here are a couple of the printouts from demo 15 from the output, just to illustrate where the models differ. All right. In conclusion, I always like to provide some helpful hints, and that is, I have 3 this week, that path modeling and SEM are complex techniques, and learning the modeling techniques requires more than just learning how to write the syntax and look at the output in Mplus. And hopefully this will, you've learned that before, and now you're learning Mplus, or this learning Mplus will motivate you, inspire you to learn path modeling and SEM. I recommend using a good textbook. Schumacher and Lomax is an excellent textbook to learn this. And the use of SEM requires solid theory to support the models, something that is the unseen backdrop for the models we discussed. Now, I talked a little bit about some of the theory behind them, but not too much. When you're running your own models, that you cannot overlook that. Here are some great resources. I didn't talk about this one yet, but Confirmatory Factor Analysis for Applied Research is a great book if you're learning about CFA. And it talks a lot about these different techniques for setting your metric. Just a reminder again, we do have some additional upcoming sessions. There's the dates. I will post materials and video demonstrations on Canvas just like this. Just want to ask you to let me know, sorry, how I can support your use of Mplus, because I'm here to support you in your use of this program. And once again, if you have any questions, please contact me. Please stay safe and respond to discussions, send me emails. I'd love to hear from you. Take care.